Before we get started with actually graphing things, I'm a little bit nervous that maybe last year we didn't learn what we needed to when it came to shifted functions in general. And that's going to be really important in a second. So we're going to just review some things. I don't think you need to take notes at this time. I just need you to look up here, pay very close attention. So shifting for all different functions from the parent function works the same way, guys. So transformation of functions, I'll say it again, works the same for all functions. So we have some function f of x. The transformation, if it's a transformation from the parent function, it'll have this form. So a couple different things. All functions have a parent function. A quadratic's parent function is x squared. Do we understand that? A cubic function is like x cubed. You get what I'm saying? A basic was not, most basic non-shifted function. Okay, so this is what the shifts are. Maybe, I guess you could take a picture of that if you wanted because you're going to need to know the shifts. Are we all good? We already know these. We've seen them before. Okay, so the a in front of the function, the a being multiplied, that f just means whatever function we're talking about. So the a being multiplied in front of the function is a stretch or compression. That's our acceleration. I want this to make sense. Let's say we're looking at a quadratic that has an a value of 1. That is no stretch or compression. 1, no stretch or compression. Now, if a is larger than 1, it's considered a stretch. Because think about it. If it's 2, for example, isn't the acceleration getting larger quicker? So do you see how that vertically stretches it up since it's getting larger quicker? Vertical stretch. So if a is greater than 1, it's a vertical stretch. If a is less than 1, let's say that a is a half, then that's less of an acceleration, so it compresses it. Does that make sense? It's going out less and up slower. Does that make sense, everybody? So it looks something like this. A is a half because it's going up slower. Does everybody see how it's compressing it? Okay, now this, anything added in with x, anything grouped with x for all functions is a shift left and right, and you go opposite of the sign. So if this was x minus 3, we would say right 3. If this was x plus 5, we would say left 5. Good. All right, and then this plus k is being added on the outside of our function. It's our shift up and down of our function. So it takes our function, shifts it up and down, and the sign stays the same. Everybody good with those shifts? Okay, last thing. This negative in front of a, if this was a negative in front, that has nothing to do with the stretch or compression. That is its own, that's its own transformation. It's a reflection over the x-axis. You need to know that. That takes it and reflects it upside down. For example, negative x squared. That's a reflection over the x-axis. It's a frowny face. Does it make sense now? Okay, awesome. So just look up here. It looks like a lot, but I'm just showing you all functions have a parent function, and then you can write shifts from the parent function. So we know how shifting works the same for all functions. So just look up here. The parent function for a quadratic is y is equal to x squared. You see how there's no shift? So looking at this, now it's shifted from the parent function. So we would say right 3, up 1, stretch of 2. Does everybody understand? You're sure? Okay, this is a cubic's parent function. Now look, this is a transformation from the parent function. We would say left 3 and a reflection over the x-axis. Everybody good? Okay, looking at this, that's an exponential's parent function for e to the x, that is. There's other types of exponentials. So what would the transformation be right here? Right 2. Down 1, right? Okay, this is a linear function, y is equal to x. That's the most basic non-shifted function. So this would be a left 1, reflection over the x-axis. Quartic, a degree 4. This is a shift of left 2, down 3, stretch of 3, and a reflection over the x-axis. Does everybody understand? Okay, this is a logarithmic function. We haven't got there. We'll get there later in the year. A logarithmic function. This is the parent function, no shifts. So this would be a right 1, down 3 of a log. Square root functions, we're going to get there next. Square root function, we have the square root of x. This is a parent function, non-shifted. This would be left 1, down 4. This is a cube root function. We're going to get there this year. So underneath, this is a parent function, so this is no shift left and right, but isn't it up 5? Okay, we're almost done. Absolute values you should have learned in previous years of math. So an absolute value function looks like this. Y is equal to the absolute value of x. That's the parent function. So this would be a right 4, up 2, and a good, a compression of a half. Very good. Now this is what we're graphing today. Here we go, rational functions. So now we're to what we're graphing today. Here's the parent function, y is equal to 1 over x. So this is a shift from the parent function. That's what we're going to be graphing today. We would say left 3, down 2. Okay, we all get how shifting works. Great. Okay, so now this is one thing you need to understand. This is the main difference between today's lesson and next lesson. A function can't always be a transformation from the parent function. Here's a general rule of thumb. If a function is a transformation from the parent function, then the shift will only have one x value. So for example, this is a shift, correct, from the parent function. There's only one x, correct? So this is a shift from the parent function x cubed, correct? That one's a yes. Looking at this one, x cubed plus 2x. Do you see how there's two x's? This is not a shift from the parent function x cubed. We all understand. So this would be graphed differently. So not a shift from the parent function. This is a shift from the parent function because there's only one x. So it's a shift from the parent function, the square root of x, it's up 2. This one's a yes. This one is a yes, a shift from the parent function 1 over x. This one's a yes. What about this rational? No. We will graph these a little bit differently. That's what we're learning next time. Not a shift from the parent function. And this would be a yes, and this would be a no. Correct, everybody? Okay, awesome. We all understand. Okay, so I want you on your whiteboards to write a quadratic function that has been shifted from the parent function left 3 down 2. So what's the quadratic's parent function? That's what you should first say to yourself. What is the parent function of a quadratic? What's the quadratic, guys? X squared. Okay. And then write an absolute value function that has been translated from the parent function. So do both of those. So we say to ourselves, the parent function is y is equal to x squared, because that's what a quadratic's parent function is. Now it's been shifted left 3. Our shift left and right's in with x. So that's y is equal to parenthesis x left 3. You got to go opposite, correct? Plus 3 squared, and then down 2. Minus 2. Now it's shifted from the parent function. So I want you to try absolute value function, do that one. So we got, this is the parent function, and it's been right 1, up 5, stretch of 3, reflection over the x-axis. So let's do it in pieces. So the right 1 is your shift left and right is grouped in with x. So x minus 1 because we go opposite. Then it says up 5, so we'll have our add 5 out here. A stretch of 3, put it in there, and a reflection over the x-axis. So we need a negative. So pretty simple. Okay, good. Do this one. Write a function that is a transformation from the parent function y is equal to 1 over x that has been translated 9 units to the right and 16 units down. So that's our parent function. It's been translated 9 units to the right. Isn't shift left and right grouped in with x? So we should have y is equal to 1 over grouped in with x minus 9, and then it's 16 units down, so minus 16. That's a shift from the parent function. Okay, sweet. Let's get started. So here's 4-5. If you want to take a picture, you can. I'm going to erase this before you even see it. That was bad. Okay. So everybody, we're going to be taking today and graphing shifted from the parent function f of x is equal to 1 over x. We're going to take this graph and shift it around. So we're going to move it left and right, up and down. And so there's some key features you've got to look at on this graph here. So a couple different things here. So I want you to look, so this is the graph, the black thing here. Does everybody see it? There are these things on this graph called asymptotes. Do you see the red dotted lines? Those are called asymptotes. So let's all laugh because everyone's like, that sounds like a bad word. Asymptotes, let's all say it and get out of our system. Oh, good job. I'm proud of you for being mature. So anyways, these asymptotes this is basically what an asymptote is, and I'll show you how we get these asymptotes in a second. An asymptote is it's not actually there. We just draw the dotted line so we can actually draw our function in really pretty here. So it goes without being said that those are not actual lines. Do we all understand that? Okay, asymptotes are values where your graph gets really, really, really close to, but usually doesn't ever cross it. Does that make sense? So do you see how this is coming down and getting closer and closer to the asymptote? Everybody good with that? This is coming up and getting closer and closer to the asymptote. And then this is circling up, getting closer and closer to that asymptote, and this is circling and getting closer and closer to that asymptote. It usually does not cross the asymptote. However, there are rare occasions when it will cross. But even if it did cross, it's going to hug it and stay really close to it. Does that make sense, everybody? Yeah. Okay. So this is where those asymptotes come from. What value of x can we not divide by? 0. So x cannot be 0. So let's look on our graph at where x equals 0. Isn't that this asymptote? I'm going to highlight it right here. Isn't that x equals 0? So do you see how our graph is coming in hot but never crossing 0? X equals 0. So that's why that asymptote is there. Does that make sense, everybody? Okay, and then so that's good enough. So that's called our vertical asymptote. You need to know what vertical versus horizontal. Vertical, if you do a vertical jump, you're jumping up. That's how I remember it. So our vertical asymptote is that x equals 0 of the parent function. Now a horizontal asymptote, this is our horizontal asymptote right here, this one. Now, how I remember that it's this way is the horizon, the sun rises like this, correct? So that's how I remember that this is considered my horizontal asymptote. Okay, and now where that comes from is this. So horizontal asymptotes are the end behavior of our graph. Now here's why. Let's plug in some XY points here first of all. This is really going to help you understand next time. So let's plug in, we won't plug in 0 into the function because we know that that's an asymptote. It's never going to be 0. Let's plug in -1. What's 1 divided by -1? -1. So do you see how -1 is a point on a graph? Yeah. Okay, let's do a value that's really large. For example, let's do maybe like -8 over here. So let's plug in -8. Take your calculator. Everybody take it. Do 1 divided by -8. Tell me what you get. -0.1225. So isn't that pretty close to 0? So we're going -8 and then negative down barely any. Does that make sense, everybody? Did you see how it's really, really close to 0? That's where this asymptote is coming from, because the larger, think about it. Now let's say we divided by something even larger than -8. Want to be even smaller? Even closer to 0. Does everybody see what I'm saying? So that's where that asymptote is coming from. Let's plug in something. Let's plug in 1 into our function. Plug in 1. 1 divided by 1 is 1, so that's on our graph. Sweet. Now let's plug in a really large value for x. Let's plug in 100. So 1 divided by 100, what do we get? 0.01. Isn't that pretty much 0? So do you see where this asymptote, the horizontal asymptote, is coming from? The end behavior. Okay, awesome. Okay, so now we're going to take and we're going to shift this around. Actually, I really want to show you this because I think it's kind of cool. So pull up your calculator, go to y equals, pull it up. Because if you're understanding the asymptotes deeply, it's going to make the next time's lesson much easier. And most of you are going to take pre-calculus and you'll relearn this in pre-calculus. And you'll already know it because I will have taught it to you. So we have 1 divided by x. That's our function. Let's go look at the table of values just for kicks and giggles. Now notice how it says error at 0. That makes sense because we can't divide by 0. That's where our horizontal asymptote came in, because x cannot equal 0. And x is our horizontal asymptote, correct? X cannot equal 0, so then we drew in an asymptote at x equals 0. Now scroll up. Let's get really, really small on x. You see how as you scroll and you get smaller on x, we're getting once again closer and closer to 0. See how as the larger we get, the closer and closer we get to 0, the smaller and smaller. Okay, and then the larger we get, let's scroll to the large values of x. As we get larger and larger, we're getting smaller and smaller, getting closer and closer to 0. So the end behavior is where our horizontal asymptote comes from. Pretty cool stuff. Okay, so that's why our graph is looking the way it does. So cool. So now we're going to be taking and shifting this. We're going to be transforming it with the shifts we just talked about. Now think about it, guys. If we take and shift this, won't we just be moving the asymptotes? Like let's say we shifted this function back 2 up 3. That would be going back 2 up 3. That would just shift our asymptotes with us. Everybody see that? Okay, so then we would just be able to then graph it. So we'll go step-by-step process here. So I want us to do the domain and range real quick of the parent function, and then we'll start doing the shifted function. So the domain means where's my function growing from left to right? Guys, please try to really pay attention and make sense of this, because otherwise it's going to be really hard. Our domain is where's my function growing from left to right? Didn't we already know from the equation that the only value it cannot equal, our domain, is 0? So, and it makes sense. Look at the graph. Are we coming in from negative infinity for x, but then not crossing 0? And then are we starting after 0 again and growing to positive infinity? So you would need to write your answer in this interval notation. Let's all learn it because some of us haven't seen it very much before. So our domain was negative infinity up to 0. Now, not including 0, so we have to put parentheses. The 0 is not in the domain. And then we put this little u to say union, which just means and in math terms. Yeah. And 0 to positive infinity is also in our domain, which makes sense. Zoop and zoop. There's our domain. Everybody's seeing it. Okay, our range is y values. So all possible y values here. So we're coming up from negative infinity up to 0, correct? On the y value, look at this horizontal asymptote. Isn't that the y value that it's not equaling? It's getting close to it. So we're coming in from negative infinity up to 0. And then after that 0, then we start up. So we're growing from 0 to positive infinity. Well, they're going to be around the asymptotes. So now when we shift those asymptotes, we'll go up to the asymptote. So then our domain and range will change, but to the asymptote. Does that make sense, everybody, a little bit? Okay, I'm teaching this so much better today than I did the other day because I learned so much about what people knew and didn't know. All right, let's start practicing. So go to number 6. Now we're going to graph a shifted from the parent function rational. So it says identify the vertical asymptotes, horizontal asymptotes, domain and range of each. So remember the parent function was 1 over x. We had vertical asymptotes at x equals 0 and we had horizontal asymptotes at y equals 0. Now we're taking and transforming that. So let's describe in words the shift. Left 1, up 1, correct? Is everybody with me? So that took, we used to be at the 0 here. Our vertical asymptote used to be at 0. We're now going left 1. So go back 1 and draw in your new vertical asymptote. You can draw it in with your highlighter. I like to draw in. I'll put some highlighters on the desk. Oh, did you get another one? There you go. Draw in your vertical asymptote on your graph on your homework. We got so you would write the vertical asymptote was at x equals, did I say left 1? That's wrong. Why did no one correct me? You're not crazy usually. You're not crazy usually. I'm just thinking about 20 million things, so I make errors here and there. So we have our right 1. So our vertical asymptote was that x is equal to positive 1. Because we know that's what x value our function can equal. So our vertical asymptote is x is equal to positive 1. Does everybody understand? Which makes sense. Look, our vertical asymptote happens when our bottom equals 0. 1 minus 1 is 0, so we can't divide by 0. So that's why we're saying x cannot equal 1, correct? Okay, let's do our horizontal asymptote. We've been shifted up 1. It used to be a 0, so now it's up 1. So here's our horizontal asymptote. So we go off to the side, horizontal asymptote. Now that's a y value. Now everybody gets confused with, well, is it x or y equals? Look, x is always changing. This is x is equal to -4, but this is always y equals 1. This is x is equal to -5, but always y equals 1. So that's how I remember y equals 1. So our horizontal asymptote is at y equals 1. Does everybody understand? Okay, any questions up to here? I'm trying to go slow so we all get it. Okay, so our next step is to now graph it. Now these are what would be expected of you algebraically to do. 1, now we're just going to graph some points, correct? But these are the points in specific you need to graph. You would need to graph your x-intercept and your y-intercept, if there is one. So let's draw that out on your little paper. Let's show our work. So our x-intercept is when y equals 0. So let's plug in 0 for y and then solve. So, and I'm just going to be plotting points here. So we're plugging in 0 for y. So that's y. So we have 0 is equal to 1 over x minus 1 plus 1. Now let's solve for x because we know our y is going to be 0. We want to know what x value. So we subtract 1, correct? Negative 1 is equal to 1 over x minus 1. Now aren't we solving a rational? So we need a common denominator, right? So we multiply by x minus 1 over x minus 1. And now can't we just ignore the bottoms? So I'll put that in parentheses. So we have negative x plus 1 equals 1. We're almost done with solving for x. Subtract 1. Negative x equals, subtract 1, we get 0, correct? Divide by negative 1, so x equals 0. So we get 0, 0 is where it's crossing the y-axis. So, oh, sorry, was that x-intercept? Okay, awesome. Sorry, I meant to say where it's crossing the x-axis. So 0, 0 is where it's crossing the x-axis. Is everybody good with that? Now, I know that how asymptotes work is this is going to, because it's in this region down here, this region, I know that how asymptotes works is this is going to come and get really close to that asymptote, and it's going to curve down and get really close to that asymptote. Is everybody good with that? Okay, let's do our y-intercept, which let's think about this. Isn't it our y-intercept going to be the same for this one? Isn't that it's also crossing the y-axis? So we could just plug it in, but we'll get 0, 0 again. Okay, awesome. So then I say to myself, well, where's my graph? Because there's more to it. So wouldn't I want to test some values on this side of the blue asymptote? Because then if I plug something in, I'll get something out. And if I'm up here, I know it's up here like this. Does that make sense? So let's test another value. Let's test 2, for example. So plug in 2 into your function. So I'm going to do that right here, not the y-intercept, but I'm plugging in 2. So we have 1 over 2 minus 1 plus 1. That's 1 over 1 plus 1, which is 2. So we had a point over 2 up 2. Is everybody good with that? We plugged in 2 and we got out 2, so they happen to be the same. So we're going over 2 up 2. Now I know it's in this region of the graph, and how asymptotes work is this is going to get really, really close to those asymptotes that never cross. And we graphed it. Yep. Now I want to try to make some sense of some things so that tomorrow's a lot, or next time's a lot easier. Let's make sense of why, well, we know why this the vertical asymptote is 1, correct? Because the bottom cannot equal 0. So now it's preventing the function from actually the x values from ever being 1. Now think about this. Okay, so if we plug in, because we know that the horizontal asymptote, the red one, comes from our end, is what's happening at our end behavior here, where our graph is approaching. So let's plug in, like, why not plug in infinity? Okay, so 1 divided by affinity minus 1, isn't that going to be a positive? I'm trying to decide if that's the best example to use. Okay, this is a good example. Let's try something smaller so that hopefully you can picture it better. Let's try 100. Everybody type in your calculator. 1 divided by 100 minus 1. Nope, just in your regular old thing. 100 minus 1, and then we have plus 1. So, isn't that 1 over 99 plus 1? Which is 1 over 99 plus 1. Now think about it. Isn't 1 divided by 99 basically 0? So isn't this just going to be basically, the answer is basically 1? Correct, everybody? So aren't we just, so do you see how as x gets larger and larger, we're just getting, every time we're going to get closer and closer to 1. Now if I plug in something bigger than 100, won't it be even, this piece will be even closer to 0, correct? And then, so 0 plus 1 is 1. Is Does everybody see where it's coming from? Okay, awesome. Okay, let's do another one on your worksheet. Here we go. So we would say, okay, I can graph this, and now this one will go much. Oh, we didn't do domain and range. Really important. Here we go. So domain is negative infinity up to the asymptote, right? Negative infinity up to 1. And then after that, 1 to infinity, correct? So union 1 to infinity. Does everybody understand? Okay, our range is our y values. So aren't they all approaching up to the asymptote? So negative infinity up to 1. Union, and then after 1, y equals 1, is growing to positive infinity. So our domain and range we could have got from the beginning, knowing our vertical and horizontal asymptote. Everybody understand? Okay, let's do another one. Okay, so number 1, we would say, okay, I'm going to figure out my new asymptotes by determining the shift. So we're going to right 2, down 1. So our right 2 will be our new vertical asymptote. Right 2, put in your vertical asymptote. So I'm going to go off to the side and write my vertical asymptote is that x equals 2. Now we know that that is true because if we plug in 2 minus 2, that'd be 0. We can't have the bottom equal 0. So our asymptote prevents it from ever crossing that. Now down 1, so our horizontal asymptote is at negative 1. Y is equal to negative 1. Okay, sweet. So now what we would do is, well, why not do the domain and range right now? We only need the asymptotes for that, right? Don't we? Yeah. So let's do domain and range right now. So domain is negative infinity up to 2. Good. Negative infinity up to 2. And then from 2 to infinity. And our range is negative infinity up to negative 1. And then negative 1 to positive infinity. Now let's graph it. So what we would want you to do is x and y intercept. So x-intercept, y-intercept. So our x-intercept is when y equals 0, plug in 0. So we have 0 is equal to negative 3 over x minus 2 minus 1. So we'd add 1. 1 is equal to negative 3 over x minus 2. We're trying to solve for x. We're just plotting x, y points. We are plugging in y is 0. So then we get a common denominator. Multiply by x minus 2 over x minus 2. Now we can ignore the bottoms. Distribute 1 through. So we have x minus 2 equals negative 3. Won't we then add 2? So x equals negative 1. So we have a point negative 1 up 0. Boom. Now everybody look. Do you see how in our graph it's in this region right here? So we know how asymptotes work. It's going to come down and get close to the asymptote. Now before I graph this side, do you see how we would be crossing the y-axis? Let's do our y-intercept first. So our y-intercept is when x equals 0. So we have negative 3 over 0 minus 2 minus 1. So we have negative 3 divided by negative 2 minus 1. Type that into your calculator. So 3/2 minus 1. You see what I'm doing? I'm just... yeah. It's positive, negative. You probably didn't type it. Here's what you need to type in. Make sure you use parentheses. So that's 1.5 minus 1, which is 0.5. So we're going over 0 up at 0.5. So right there. So now we know it's crossing the y-axis right there and going to come really close to our asymptote. Now we have more to our graph. So notice we've graphed all of this side of x, correct? Let's graph this side of x. So let's plug in, why not 3? You see how I'm just plotting another point. Plug in 3, negative 3, divided by 3 minus 2 minus 1. So that is negative 3 over 1 minus 1. Negative 3 minus 1 is negative 4. So 3, negative 4 is another point on the graph. Over 3, down 1, 2, 3, and 4. So now I know it's in this region right here. So let's graph it in, getting close to our asymptotes. Pretty simple, right? For the most part, it's a lot of thought, yes. But not too bad, hopefully. Are you feeling okay? Do you want one more example, or are you ready to practice? Last example, okay. This one, let's fly through it. Okay, here we go. This is number 4. So here we go. It says, so let's identify the vertical asymptote. So there's no shift left and right, correct? 0. So at 0, it stayed. So our vertical asymptote is x equals 0. Now, why does that make sense? Because we can't divide by 0, so that asymptote's preventing that from happening. Our horizontal asymptote is going to be, can anyone just tell me? Oh, I mean, you can see it, down 1, correct? So -1 is our horizontal asymptote. So y equals -1. So now we would say, okay, let's be smart about this. Look at your y-axis. Isn't it an asymptote? So will we have a y-intercept? Will it ever cross the y-axis? Nope, so we're not going to do y-intercept. Let's do x-intercept though. So x-intercept is when y equals 0. So plug in 0 is equal to -1 over x minus 1. Solving for x, you'd add 1. 1 is equal to -1 over x. We need a common denominator multiplied by x over x. Now we can ignore the denominators. So we have x is equal to -1. So our x-intercept was -1 of 0. So x is equal to -1 and y was 0. So that's a point. So we know our x-intercept is at -1 of 0. It's crossing the x-axis right there. So now we know it's in this region. It's going to come down, approach that asymptote, approach that asymptote. Now, let's plug in. We know everything on this side of x. I'm going to just draw an arrow so everyone can see we already drew in everything on this side of x. So let's draw in, let's figure out where our graph is on that side of x. So let's plug in 1. Okay. So we're plotting a point here, so we plug in 1. -1 divided by 1 minus 1. Isn't that -1 minus 1? -2. So we're going over 1 down 2. Boom. Okay, now I know I'm in this region. Getting close to my asymptotes. Let's do domain and range. Domain. -infinity up to 0. Union 0 to infinity. And our range is -infinity up to -1. Union -1 to positive infinity. So our asymptotes make domain and range just very, very, very quick. Okay. If you have questions, please draw in your asymptotes with highlighter, because then it's easy for me to check and it's easy for you to see where your asymptotes are. Questions on any of this? That's it. That's all you're learning today. Yes.